So Simpson's rule uses parabolas instead of rectangles or trapezoids. So uses parabolas to estimate the value of a definite integral. Now here's something you might not remember, but I'll ask this question anyway, or maybe it was never presented to you quite this way. How many points do I need to determine a parabola? 3. We need 3 points to determine a parabola. So to determine a parabola, we need 3 points. So because of the 3 points, we're going to use 2 adjacent subintervals on my graph to get the 3 points. So it's not just like the left side and the right side or the middle. It's going to be 2 of these together, and we'll use the 3 points we get from the 2 of them together. Because of this, we need 2 adjacent subintervals to get the 3 points. And they have in the book gone through kind of explaining about where the things come from on this formula. I'm just going to put the formula up here. This is for Simpson's. I'll put S sub n. Let me also write this. The integral from a to b of f of x dx is about equal to S sub n, which will be delta x over 3, I'll open brackets, f at the first x value, which I'll call x sub 0, plus 4 times f at the second x value, plus 2 times f at the next x value. So what I call the first one is x sub 0, x sub 1, x sub 2. Then 4 times f at the next x value, plus 2 times f at the next x value, which would be x sub 4 in this case, plus 4 times f at x sub 5. The 4 and the 2 are going to alternate. I'll do plus, dot, 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 plus, and then I'll write the last few terms here. 2 times f at the value x sub n minus 2, plus 4 times f at the value x sub n minus 1. Then the last y value stands alone. It's not multiplied by anything. So there's a formula for Simpson's rule. And I do want to do Simpson's rule with this graph that I've been having going on for the last couple of days here. Oh, one thing about Simpson's rule, I've kind of maybe implied this a little bit, but n must be even. That's because of the 2 subintervals. You're going to take them 2 at a time. N must be an even number. So for my graph I have going on here, we're going to do now Simpson's rule. With n equals 6. But that's going to be 3 parabolas. Like I'll do, let me use a pencil for this. The middle of, here's the 6, but my 3 points, the left, the middle, and the right, for this is my first, the top is parabola shape. Now this is an odd problem to do this with, but it's also creates something kind of interesting. The next two, I have this one that I had used on the previous, and this one. Now you do the parabola that fits through those 3 points. I'm going to put this one in blue. Now look, this is a kind of a strange problem to do Simpson's rule with. Do y'all notice something kind of strange about it? Let's just keep working it. Okay. And I'm saying strange. Strange might not be the correct word. So I'm going to find the area that's enclosed by what I've highlighted there. Well, actually, we're just going to use Simpson's rule. So let's do it. Simpson's rule is this. We're doing S sub 6. It is delta x over 3 plus, not plus, times f. The first x sub 0 is this one right here. X is 0, y is 3. So that's f at 0. Here, I'll fill in my f at numbers this time. So it's going to be 4 and f at 1/2 plus 2 times f at 1 plus 4 times f at 3/2 plus 2 times f at 2 plus 4 times f at 5/2. Then f of 3, the last one, is not multiplied by a number. And I didn't put it in here, but let's go ahead and put this in here. What is delta x? Delta x is still 1/2. For that, we're looking at 1, 2, 3, 4, 5, 6. There's the 6 subintervals. Delta x is still 1/2. So let me go ahead and put that in there. And I started to write this on the graph. I didn't write it across the whole thing. But let's go ahead and put this in here. 0, 3. Here, this point's 1/2, 13/4. This one is 1/4. This one is 3/2, 21/4. This one is 2/7. And then I have 5/2, 37/4. And then finally, 3/12. Okay, I did tell you to take your calculators out at the beginning of class, so we're going to go ahead and calculate this one with the calculators. This will be S sub 6. I'll write this out and you can start plugging it in. Well, I have 1/2 over 3. What is 1/2 over 3? That would be 1 over 6. So f of 0, that's 3. 4 times f at 1/2, that's 13/4. 2 times f of 1, that's 4. 4 times f of 3/2, that's 21/4. And then 2 times f of 2 is 7. 4 times f of 5 halves. F of 5 halves is 37 over 4. And then f of 3, that's just plus 12. Well, this isn't going to be nearly as bad as I thought it'd be, because a lot of this is going to reduce pretty quick. 1/6 times 3 plus 13 plus 8 plus 21 plus 14 plus 37 plus 12. Somebody got the answer yet? 18, thank you. First time I worked this problem, I was like, oh my gosh, what did I get? I got the real answer. Why? Because what? This problem is a parabola, right? It's a perfect fit. Okay, that's just because the problem I'm working already is a parabola. Normally, Simpson's rule, if it's not a parabola, you shouldn't expect it to be a perfect fit. But this one is.